water and pipelines because, as you can see, there are a lot of pipelines in Pennsylvania. Pipelines have been proposed for Columbia County, but as you may have noticed, it is not a done deal. These are both oil and gas pipelines. This is courtesy of the pipeline safety website. Part of the problem with pipelines and water is how they're constructed. You can see in this picture from Lycoming County that there is a lot of heavy equipment involved. Heavy equipment tends to compact soil. If soil is compacted, water can't percolate in, it tends to run off. If it is running off and there's a lot of soil exposed, that means that water will take that soil and deposit it wherever it happens to be traveling, probably in Pennsylvania where we have lots of streams, into a stream. Another problem with the way it's constructed and the compaction involves the fact that less groundwater potentially can percolate into the ground. This may not be an issue in some places, but in other places where, say, water suppliers for the public or people with residential wells, Pennsylvania is second only to Michigan in the number of residential wells. Those wells could be experiencing reduced infiltration, so groundwater tables could be affected by pipelines. Another thing to think about when we're thinking about pipelines and water is carbonate rocks. You probably know them more colloquially as limestone. And you can see the blue on the diagram up there is the limestone and dolomite rocks that are exposed in Pennsylvania close to the surface. Limestone in particular can be dangerous because it's soluble. Rainwater is naturally a little bit acidic, and when it falls and percolates into the ground, it'll follow along fractures, and if it's soluble rock, it will dissolve it and make those fractures a little bit bigger, and the little bit bigger fractures can turn into conduits, and the conduits can turn into caves, and caves can occasionally collapse and make sinkholes. And when you are putting a pipeline across this kind of ground, even if you exercise due diligence, there is still the chance that you could change the hydrology of the area. You can compact and maybe cut off drains that were actually open, so you'd have water ponding on the surface, which you would not have originally had. You could also open up drains, open up conduits that were not previously open into the subsurface groundwater system, and that means you may potentially have things draining into the subsurface, into aquifers that are used for residential wells, for public water supplies, that you were not previously intending to have in there. An example, this just shows this is a famous diagram amongst karst hydrogeologists showing what typical ground over limestone bedrock might look like. The low spots, the layers are limestone. The low spots are places where groundwater has percolated in and dissolved away some of the bedrock. And you can see if you put a pipeline through there, if you dug in the wrong spot, you could sort of open up some of those places where there's soil, plugging up the holes, and allow much more water to flow downward, which could be a good thing. It could also be a bad thing depending on what it's carrying with it. Another thing you can notice is how uneven the surface of the bedrock is. Again, it's hard to tell without geophysical surveys exactly where the highs and lows in bedrock are and what's going to be stable and what's not going to be stable. So you have to be very careful if you're putting a pipeline through this kind of area because you don't necessarily know how stable the rock underneath the pipeline is going to be, and if something shifts, that could cause problems with the pipeline, cause problems with leaks. If it's dry gas going through the pipeline, the gas will, sorry, this is a rather, I feel like I'm zooming in and out. All right. If it's dry gas, the gas is going to try to escape. If it's something else in the pipeline, a liquid that's heavier than air, or a liquid like oil, it's going to sink down into the rock, possibly into the aquifers. And just to show you a representative sinkhole from Pennsylvania, this is another famous one from Lehigh County, one of the counties that has a lot of karst, a lot of limestone at the surface. And this happened without anybody digging anything at the surface at all. Another thing we have to be careful about are mined areas when we're thinking about how stable is the subsurface. You guys are all familiar with coal mining in Pennsylvania. This shows coal mines. Remember, especially around here, there's more than coal mines. We've got iron mines. We've got holes in the sides of hills that, our kids know about, people have explored when they were teenagers, and they may be stable, they may not be stable. There are old lead mines, there are old zinc mines scattered around Pennsylvania. And even with the coal mines, we don't always have good records of exactly where the subsurface mines were. So we need to be careful, because if that ground isn't stable, pipelines can crack. And again, if it's carrying gas, the gas is going to move upward. If it's carrying something else, that could end up in the subsurface. Something you might not think about is acid-producing rocks. It's not just coal that makes acid mine drainage. Anything that has sulfur in it can potentially produce acid drainage. And when you disturb the soil and you crunch up that rock and you let water percolate through it, it picks up the sulfur. Sulfur plus water makes sulfuric acid that causes acid mine drainage. Down in the corner there is an example, Skytop in Center County, where they crunched up some nice looking sandstone to make a road base and created a horrible acid drainage problem with pH of less than 3, neutral is 7, so 3 is bad, 3 is like almost lemon juice. This is a serious problem to anyone who has a well in the area, to streams and rivers in areas where this material is pulverized and then used to backfill along a pipeline. Another problem is sediment. If a water supplier, a public water supply that draws water from a river knows sediment's coming, like in this case, this is Fishing Creek and it was raining. So this is what happens to Fishing Creek when it's raining. If somebody's putting a stream crossing through and the water company doesn't know it's coming, that could potentially be a problem for the water supply. I heard that in 39 miles of pipeline in Sullivan County, 122 sensitive stream crossings. And even if they try to do it, the preferred method to go under the stream, there's people who've witnessed the drilling fail in bentonite mud, go down the stream for miles. That is not good for aquatic organisms. We have in Columbia County a few high quality and exceptional value watersheds. Notice that's just the watersheds. There are individual streams that are higher quality, and you can get a sense of that from this map, which shows you wild trout streams. Wild trout streams in blue, Class A trout streams in green. We have a lot of those in Columbia County, and a tremendous amount of sediment is not going to be particularly good for wild trout populations. I just threw that in because it's pretty. Public water supplies. Now this shows public water supplies in Pennsylvania, and the ones with blue dots represent ones that have source water protection plans. That means they know where their water is coming from, and they know the areas that they need to protect. The red dots means they don't have a source water protection plan, so they don't know what areas to protect. This is a little bit old, so let me show you. Oops, sorry, another slide first. And just so that you know, for groundwater, there are zones that must be protected, 100 to 400 feet. A 10-year time of travel zone, that should be protected. But in reality, pretty much the whole watershed that's feeding water to that well, that's a public water supply, that is ultimately going to be a source of water for that public water supply. So we need to think longer than 10 years down the road when we're thinking about pipelines. For surface water, that would be municipalities such as Bloomsburg, such as Danville, such as Catawissa sometimes. They get water from surface water. You've got a quarter-mile sort of emergency management area, quarter-mile, 2-mile, or 25-hour time of travel, although those who know Fishing Creek know that water will travel substantially faster than that. And for Zone C, really, if you want to protect your drinking water, you've got to protect the whole watershed. In Columbia County, we have some of our municipalities have these source water protection plans. When United Water's new plant gets up and running, they're going to have a source water protection plan. But you can see there are large swaths of our county that we have to think about in terms of how is groundwater and surface water, especially with a pipeline, how are those going to be affected? Sorry. This is a picture of Catawissa. The yellow dots are the 10-year time of travel. The blue coloring shows you the size of the watershed, and actually they can't even fit the whole watershed on that slide. So down in the corner, it shows you the whole area that really should be considered when you're thinking about the safety of the water supply for Catawissa. We need to think about all this because we know that accidents happen. This is a map from ProPublica showing all of the significant incidents, which John defined for you earlier, greater than 50 barrels, greater than $50,000, somebody injured or dead, and I forget what the other criterion is. But anyway, these accidents do happen. And again, these are only the significant ones. These are not the incidents that count as insignificant. And I should point out that in addition to these local specific possibilities of impacts from gas pipelines, there's also the chance that if you put in a pipeline, you have greater incentive to drill. And if you have greater incentive to drill, then you have fracking water to come up with. What is going to be your water supply? You have fracking waste to deal with. What are you going to do with your flowback water? Are we going to keep sending it to Ohio and giving them earthquakes? Is that what we want to do? I think John's question of you have to decide if this is what is right for you applies very well here. And then just a picture of happy professors and students in one of our streams. And that's all for me.